Hello, my dear fellow friends and respected teachers. I am Khushi, a student of 12th standard studying in Amrit Indo-Canadian Academy. Today, I am here to explain a new topic from class 12 chemistry. So, without wasting much of your time, I am proceeding to my topic, that is role of carbocations during the preparation of haloalkanes from alkenes. First, let us start from basics. Do you know what are alkenes, haloalkanes, or carbocations? Let me explain them one by one. So, alkenes are unsaturated hydrocarbons containing carbon-carbon double bond in their molecules. Their general formula is CnH2n. Now, these are some of the examples of alkenes. There are two types of alkenes, symmetrical alkenes and unsymmetrical alkenes. Symmetrical alkenes are those which when divided from the double bond bear two equal halves. For example, butene. It is a symmetrical alkene. How? Let us see. Now, this is the formula for butene. If we divide it from the center, that is from the double bond, we will get C2H4 on both the sides of the double bond. So, it is a symmetrical alkene. Now, what is an unsymmetrical alkene? An unsymmetrical alkene is the one in which the groups or atoms attached to the either end of the carbon-carbon double bond are different. For example, in propene, there is one hydrogen and one methyl group at one end of the double bond, but two hydrogen atoms on the other end of the double bond. So, it is an unsymmetrical alkene. Now, let us understand what are haloalkanes. Haloalkanes or alkyl halides are the derivatives of alkanes in which one or more hydrogen atom is being replaced by a halogen atom. For example, CHCl3, also known as trichloromethane, is an example of trihaloalkane. Why tri? Because three halogen atoms are present. Now, what is a carbocation? Carbocations are carbon atoms which have only 6 electrons in their valence shell, making them electron deficient and therefore very reactive. Now, let us understand the mechanism of addition of halogenic acid to alkenes in a general form. Mainly, it is a two-stepped process. In step 1, AB. Here A is the hydrogen atom and B is any halogen like fluorine, chlorine, bromine or iodine. Now, the AB bond gets polarized and B gets a partial negative charge due to higher electronegativity than A. Similarly, A acquires a partial positive charge. As this molecule is brought closer to an alkene, the pi bond of the double bond gets repelled due to the electron cloud of attacking reagent. As a result, the nearer end acquires a partial positive charge and the other end acquires a partial negative charge. At the same time, there is a shift of pi electron pair of one carbon atom to other. Thus, this carbon atom gets positively charged and the other carbon atom gets negatively charged. Then, the positively charged atom, that is A in this case, attacks the molecule and gets attached at the negative carbon atom and forms a new carbon atom bond. This leaves the other carbon atom with positive charge and an intermediate carbocation is formed. Now let's see what happens in step 2. In step 2, the anion, that is the negatively charged atom, attacks at the positive carbon atom to form a new addition product. So, this was the case when the alkene is symmetrical. For example, in case of ethene and hydrogen bromide. Now what if the alkene is unsymmetrical? Let's see. In case of unsymmetrical alkenes, the addition reaction is governed by Markovnikov Rule. Now, Markovnikov Rule states that during the addition across unsymmetrical multiple bonds, the negative part, that is the halogen in this case, of the attacking reagent joins the carbon atom with smaller number of hydrogen atoms, while the positive part, that is hydrogen, goes to the carbon atom with more hydrogen atoms. Now, let us take the example of hydrogen bromide being added to propene. Now, as you can see on the screen, the first step is hydrogen and bromide getting ionized. So, anion bromine and cation hydrogen is formed. In the second step, the positive part, that is the hydrogen ion, moves to the carbon atom with negative charge and a secondary carbocation is formed. In the third step, the negatively charged bromide ion moves to the positively charged carbon atom and a haloalkane is formed, that is 2-bromopropane. During the reaction, two types of carbocations can be formed. One, secondary carbocation, and second, primary carbocation. Secondary carbocation will be formed when hydrogen ion will join the terminal carbon atom, that is the carbon atom which is located at the end. And primary carbocation will be formed when hydrogen ion joins the central carbon atom. Can you explain the reason why in most cases secondary carbocation is formed, not primary? For this is because secondary carbocation is more stable than the primary carbocation. Therefore, due to the possibility of formation of two types of carbocation, two types of end products are also possible. As you can see on the screen, if secondary carbocation is formed, the product will be 2-bromopropane because bromine ion will get attached at the central carbon atom, that is at the second position. And if primary carbocation is formed, the product will be 1-bromopropane because the bromine ion will join the terminal carbon atom. 1-bromopropane can also be obtained by adding peroxide, and this process is governed by the rule called anti-Markovnikov rule or the peroxide rule. Now you can see the procedure through this animation. This is the reaction of hydrogen bromide with propene. Now you can see on the screen that on the left hand side it is shown an unsymmetrical molecule, that is propene, and on right hand side they have shown a symmetrical molecule, that is ethene. The HBr bond gets polarized and the positive ion hydrogen gets attached towards the negative carbon atom and the negative ion, that is bromine, gets attached towards the positive carbon atom. First carbocation that was formed was secondary carbocation, and now primary carbocation has been formed. We know that secondary carbocation is more stable as compared to the primary carbocation. Now, the product that is formed by the secondary carbocation is the major product, that is 2-bromopropane. On the other hand, 1-bromopropane is formed. To sum up, we can say that the addition of HBr to propene gives 2-bromopropane in the absence of peroxides and 1-bromopropane in the presence of peroxide. So, with this, I end up the session and thank you for lending your precious time to me.